Hello, and welcome to another video. In this video, I'd like to talk about what I think might be one of the biggest differences between high school and college in terms of classes, and that is the expectation that you learn a lot of the material on your own from the material that professors provide. And in chemistry and biology, those sources are largely the textbook. And my experience is that a lot of students are unfamiliar with really how to use a textbook. And notice I say use and not read, because a textbook isn't meant to be read from page 1 to page 936, left to right, top to bottom. We have to use a textbook. We have to work with it and the content that's within it. So we have to figure out how we ourselves best gain information and learn from the material that's in there. So what I'm going to talk about today is how to work through a chapter in a textbook. That's, I think, a valuable way to do this. But before I do that, I just want to talk about the value of textbooks in the first place. So, for example, here's the general chemistry, the hardcover general chemistry book. I'll be talking about how to get a hold of a PDF online free of our textbook. So we deliberately use a free textbook so that it's available to you and it's something you have access to right now. But the first chapter in that general chemistry textbook covers topics like SI units, the systematic units that we use for length and mass and time, right? So that's one topic. Another topic is significant figures. You might have heard about sig figs and how to count sig figs. We're going to actually talk more about that in this video and in a later video. The chapter 1 also talks about accuracy and precision. It also talks about classifying matter. It has conversion problems within it, or discusses conversions, and it also has different temperature scales. So imagine that all those topics I just said, I want you to go and I want you to learn all about those topics, and I don't give you any resource. Most of us these days turn to Google, right? So we would Google temperature scales. So when we do that, our inclination again, and mine's the same as yours, is to go to the first 1 or 2 websites, and maybe they're good, maybe they're not, and maybe we learn something from them, and maybe we don't, and maybe they're confusing, or maybe they're not, and one's written differently than the other, and sometimes they seem to contradict each other, or it's hard to put them together. So we do that with temperature scales. And then we'd have to do that again with SI units, and I'd have to type in SI units, and I'd have to find a site, and maybe it's an academic site, or maybe it's NASA or wherever, and each one of those sites has a different purpose. They've been set up for different reasons. So they don't all necessarily want to try to teach you something. And then we do that for sig figs, and by the end of that, you would say, by gosh, why doesn't somebody just put all this stuff in one place so that I can learn it more easily? Well, guess what? They do. It's called the textbook, right? So we sometimes get oppressed by this and how big they are and stuff, but what has happened in producing this is somebody has lovingly gone through all of the different stuff about chemistry and said, you know what, I want to put what I think is important in one place, and I want to write it in a consistent style, and I'm going to do it with teaching in mind so that people can try to understand it from what I write, and I'm going to put this out there. And this group has actually done it for free. So they've made a PDF of everything that they thought was important and wrote in a way that is helpful to learning it in a PDF, one-stop shopping. I myself have written 2 textbooks for a different class that I teach. So I know the process, I know how authors think. And please believe me that the author is thinking, how do I teach this the best to somebody who's reading it? And not every website necessarily takes that approach. A website is just dumping information often. So the textbook is really a tool to be used, and I hope you view it as a welcome one, because it does save us a lot of time. The fact that people have gone through, whittled down all of the information that's possible and put it all in one place is really a wonderful thing for all of us. So to get the textbook that we're going to use, I'm just going to put this up if you go to www.openstacks.org and then go to subjects and then science, you will find chemistry, second edition, and we want to specifically get the atoms first. And you'll be able to download a PDF. Okay, well, I'll put that up again. I'm sorry, you should really write this down, so I'll give you a second to copy this information or take a screenshot or whatever you want to do to make sure you get this information. Okay, so my section, and if you're enrolled in Dr. Cairns' general chemistry section, we both use that book. I will admit that Dr. Zwier and Dr. Bojorquez use a different book and a different teaching approach, more kind of group work style. But what I'm going to talk about in terms of reading a textbook is going to be applicable to all 4 sections. So I'd encourage all of you watching this to download that book and at least work through the example of how to learn from a textbook. Okay, now once you download that, what I would like you to do is find the section that talks about measurement and uncertainty. So it's section 1.5. In my hard copy book, it starts on page 36. I'll admit, I'm not sure what the PDF numbering system is, but I guarantee that if you go and find section 1.5, it should be measurement, uncertainty, accuracy, and precision. Okay, that's going to be the section we're going to focus on. In my book, it goes from page 36 to 38. Okay. And what we're going to do, what I'm going to ask you to do is read those 2 pages, 3 pages, and as you're reading them, I want you to note a couple things. Note the important things. Now, I know students tend to highlight everything and everything seems important, but be judicious about that. But what really, like if you're the author, what do you think is really the main thing that you're trying to tell the reader in this section? And also highlight anything that seems new, something you're not familiar with, or potentially confusing. And I've deliberately chosen this section because this is a section that is often confusing to students. And it's a section that doesn't need to be confusing if we just take our time with it. And that's the last thing I'm going to say in this video. That's before we get into the actual exercise of using the book, but this is an important one. The idea of stick-to-itiveness is critical in your success in chemistry and biology. And by stick-to-itiveness, I mean kind of repressing or pushing down the inclination to say, well, I didn't get it on the first try, so I'm not going to get it. If you get a problem wrong, my suggestion is don't scurry to the solution guide. Don't scurry to a tutor to say, how do I do this? Try doing it again in a different way. And in previous videos, I've used the analogy of riding a bike. If you don't ride a bike successfully the first time, you don't immediately just say, oh, hell with it, put the training wheels back on, and I'm never going to ride a bicycle again. Why we expect to be successful solving chemistry problems any more than we expect to be successful riding a bicycle or playing basketball or playing a flutophone or playing a clarinet or gosh, you know, oboe. I love the oboe, but man, what a tough instrument I would think that would be to learn how to play. Why we expect to, you know, kind of be great at chemistry right away and have no patience for making mistakes and then trying again and immediately saying to the solution manual or to somebody else, you know, just show me how to do it. And then think that we're learning from that. It's like handing somebody a clarinet and saying, here, you play that piece. Oh, okay, I heard you play it, so I must be able to play it now. It's not the way it works. And that's okay. You know, that's part of the learning process. But we do eventually want to learn how to play the clarinet, or we do eventually want to learn how to do chemistry. So the stick-to-itiveness, the trying something again, but in a slightly different manner. And in terms of the textbook, what that means is going back and rereading the material and trying to keep working through what the words mean and what the author is trying to tell us, and then applying that immediately to problems to see if we understand it. So we're going to toggle back and forth between reading a section and trying some problems. We're not going to read all 40 pages of chapter 1 and then expect to sit down and be able to do all 100 problems at the end of chapter 1 that deal with 9 different topics. It's not a reasonable expectation for anybody. I wouldn't be able to do that. None of my colleagues would be able to do that, and we don't expect you to be able to do that. What we do expect you to do is chunk up the information in bite-sized pieces. Whatever we can't swallow initially, we have to keep chewing on. And then once we think we have it, try applying it to problems. And that will be the proof that we do or don't understand it. And eventually, it might get to a point where we do need to ask a question to the faculty member or the tutors. And questions are great, but questions are going to be much more beneficial if you've wrestled with the material and you've tried different things. And then somebody comes in and says, yeah, but have you done this? And then you go, oh, that's how you do it, right? And I think we've all had that experience where we've worked on something for a long time and then see the thing that makes it all click. But it's only because of all that work that we've done that clicking happens. Okay, so you can end this video, we'll end this video, and then the next video follows on from this, and we'll talk more about what we're gonna do with pages 36 to 38. But at this point, go ahead and read pages 36 to 38 and read them carefully, okay? And read them slowly and mark places where you might even have to go back. And maybe even as you're reading them, go back if a sentence doesn't make sense. Stop right away and say, okay, I didn't get that. And go back to it and reread it until you think it does make some sense. Or at least mark it and say, this is something I'm gonna have to revisit. Okay, so we'll see you in the next video. Thank you very much. And remember, the textbook is your friend because somebody has gone through all the work to put it there for you, which is wonderful. I mean, think of it as a gift. What a great gift for free. So we'll see you in a bit.